Alright, so inside of both of these motors is a encoder, the tiny little one from SparkFun, and it's shooting off of the first gear in the stack. Oh, while I'm talking, make note that the two wires are crossing exactly at this point right there. Okay. All right. So there's 8 sections on that first gear. 4 shiny, 4 black. So 25% on. No. Well, whatever the math works out to. There's 8 gears, 8 teeth on the motor gear, and 36 on the first gear that I'm watching with the encoder. So that kind of gives you an idea of what I'm watching right now. And my Arduino software with the Robot X board, ting, is basically measuring the pulse width between those 4 pulses, and averaging 4 pulses, which is 1 revolution, and then getting an average time of the pulse. It's then varying the pulse width modulation frequency that's going to the motors up and down to stay at a given value, and it's doing that with both motors simultaneously. And if you notice there, if you notice the wires crossing right where my finger is,
very cool.
there.
So it actually looks like
It's been going for 10 minutes now, and it is yet to fall out of phase. It's crossing. Where's my finger? It's crossing right there. Boom. This one is just starting to get a little tiny bit late now. Just a little, but it's been 6:50. Yeah, almost 10 minutes. And they're just barely falling out of phase right now. So there you go, balancing motors. Oh, mathematically, because I have, by the way, I have all my numbers flying by right here, and I can actually pause this, and right there, motors 1751. That's at a 0. It's in microseconds. This is I divided by 10 just so my numbers could be, I could see them easier. So that's 17,510 microseconds versus 17,580. So that's 70 microseconds different on those two motors. What's the next one? 58. That's 80 microseconds different on those two motors, on the pulses. The average of 4 pulses, 1 revolution. So basically 1 revolution of each of those gears. Motor A took 1.76 milliseconds, and the other one took 1.75 milliseconds. So that ain't too bad at all. And yep, see, it's just now starting to get a little tiny bit late, just barely. It's certainly within the resolution of the 0 to 255 that I can get for my Arduino pulse width. I gotta tell you, Arduino PicAxe kicks your butt in terms of pulse width modulation and how much you can adjust it. But proof of concept, 100% on this one. Ding.